This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which I will go through some laws of logarithms. So what are logarithms? Well, remember, they are tools to help us solve exponential equations. So if we have something like this, 2 to the power of x equals 32, then remember we can solve it with logs. X would be log base 2 power 32. And I can just put this on my calculator and I get the answer, which is 5. So logs undo raising to a power, properly called exponentiation, in exactly the same way that multiplication and division undo each other, or addition and subtraction undo each other. So that's why they're really helpful when we're solving equations in which the unknown is part of the power. So what are the laws we need to know? Well, let's just take a step back and go through some index laws. You probably know this index law. If you have a base and a power and you times by the same base, you keep the same base and add the powers. So when you're multiplying powers, you add the indices. So the opposite is true for logs because they undo raising to a power. So you multiply bases, you add the powers. So with logs, if you add logs, you multiply the powers. So if I have log A of B plus log A of C, so same base, keep the same base, and this time we multiply the powers. So that is our first log law. When you add logs, you multiply the powers. Just like with index laws, you need to have the same base for this to work. So we know from index laws also that if we, instead of timesing, we divide the bases, you keep the same base and subtract the powers. So, because logs undo raising to powers, the rule is the opposite. So if you are subtracting logs, you divide the powers. So this will be equal to log A of B over C. So that is the second log law. So the third law I want to go through is sort of analogous to the power to a power rule, but I think explaining why it works might be a little bit complicated, so I'm not sort of going to go through a proof or an explanation. I'm just going to tell you the third log law, and that is if you have log base power to another power, you can just move that power to the front. So that is equal to C log A of B. So that is the third log law. And we need to know all of these log laws for this lesson. So now we're going to look at a few examples involving these laws. So now we're going to look at using these log laws to simplify some sums and differences. So let's say I have something like log base 2 of 10 plus log base 2 of 5. So that is equal to, so the rule for addition, log keep the same base and you multiply the two powers. 10 times 5 is 50. So for division, let's have log base 7 of 200 minus log base 7 of 40. So that is log, keep the same base, and 200 divide 40 is 5. Because when you're minusing the logs, you divide the powers. So if I have something like log base 6, let's say 20 to the power of 2, I can simplify that, move the second power to the front, and I get log base 6 of 20. So let's look at a few slightly more complicated examples. So let's say I wanted to simplify this expression here. So first I'm going to use the power rule. So I'm going to move the second powers all to the front. So I have 3 moves to the front this time, and I keep the same base and power. So then I'm left with something that looks like this. Now, log 4 to the power of x is sort of a like term in each of this. So if I have 2 lots of them, add 3 lots of them, and then subtract 1 lot of them, then I end up with 1 lot. Because 2 plus 3 minus 4 is just 1. So that just equals log base 4 power x. Okay, so I appreciate all the extra work you're doing to get yourself right for next year. You're an absolute superstar. This has been the luckiest maths teacher in the world. Have a wonderful day.